Hello, Mr. Holmes here. This is the final video in the series about working with characters and character representation. Before we get into this, there's some very useful concepts that we need to borrow or remind you of that actually come from mathematics. A lot of ideas in computing actually come from maths. So instead of assuming you know these things, I'm actually going to cover the maths background very quickly. So a function is defined as a rule that takes a set of values and maps those set of values using some sort of rule or transformation onto another set of values. The important thing though with a function though is that every one of these input values in our set x is only allowed to map onto one element in the set y. If we have more than one mapping, so if I had another line going from this blue dot to that red dot, there would be a many to one. So functions are strictly speaking a one to something mapping, and which means there are basically two types of functions. The first function type is what we call a one to many function, and this is where it is still a function because each element in my Venn diagram, my set X, is mapping onto exactly one element in my output set Y. And we often write this as f of x equals y, or y equals some expression. And an example of this would be f of x equal to x squared. So this dot here might represent, for example, the value of -1. This dot over here might represent the value of +1. Now both of those, if I square -1 plus 1, I will get the same answer. So this would be an example of a one-to-many function mapping. Well, it's still a function, but it's but we do have a situation where I've got more than one value on the left mapping onto a duplicate on the right. Now, why is this important? Well, it means I can't reverse it as a function, because if I reversed it, I would then have a many to one mapping. It's not, another way of looking at this is that it's not uniquely decodable. So if I want to reverse the operation, if I say to you, right, my answer is 1 and the function that I used was x squared, you can't tell me with certainty what the single answer would be, because the input could have either been a +1 or it could have been a -1. Sometimes, however, we do get this ideal situation where we have what we call a one-to-one function. So not only does each element in the input set x map onto one element on the right hand side, the set y, the output set, but each of those is a unique mapping. So we're guaranteed in this situation that there is no duplicate. And the advantage of this is that we can flip this around. We can actually drive the function in reverse, which is what we call an inverse function. So for instance, the function f of x equals 2x, so that would simply double the value of x. So if I put a 0 in there, I'll get a 0 out. I put a 1 in here, I get 2 times 1, I'd get 2 out. If I put a 2 in here, I'd get 2 times 2, which would give me a 4. And that would be unique. But I could also work it out by driving it the other way. So I could work out the reverse of that, which means going in reverse, instead of doubling things, I would just simply halve them. So a 0 halved is still 0, 2 halved would be 1, and 4 halved would be 2. And so I could actually turn this on its head. I could turn the outputs into the inputs and create another function going the opposite way. And this function going the opposite way is known as the inverse function. So if you like, if I've defined f of x equal to y is what's being produced this way, I could define another function g of x going, like I said, I create this inverse function could be called g of y. And I could just do a simple substitution here. So I replace, so I know that g of y will in fact just give me what I started with, because it undoes itself. So and I'm just doing a simple substitution, replacing if I replace the 2x and the half x now, do all the substitution, a half x times 2x is simply going to be x. And this is what we call the inverse function, and this always happens. So if I nest, if I do the normal function, f of x, onto the set y, and then I call the inverse function around that, I will just end up where I started. I'll just end up back at x. And this inverse function, the notation we use is f at minus 1. Okay, this is known as the inverse function. So f at minus 1 of f of x is always going to be x. I could also have written this the other way around, so I could have gone f of x of f of inverse x would still give me x, because the one would undo the other. Right, so what does this all have to do with characters, you may ask? Well, a great deal, really, because there is a functional relationship between the ASCII character set, as we've learned, that there's a unique mapping or unique function that turns the ASCII codes. 48 always maps onto the character for 0, 65 always maps onto the character for capital A, and 97 always maps onto the lowercase character a. And we can use this in both pseudocode and code. There's a predefined function that does this for us, that turns an ASCII code, which is just going to be a decimal number, into its equivalent character. And that function is called CHR, for character, obviously. So if I go CHR of 48, I will always get the character 0. If I go CHR 65, I will get the character capital A, and CHR 97 will give me the character little lowercase a. Now, as you would expect, because we've already talked about inverse function, the reverse is also true. I can drive this operation in the opposite direction, and there's an inverse function. The only problem, the concept of this idea is exactly the same. The problem is that we have a slightly different name for these functions in pseudocode as we do in Python, and it varies from one programming language to another. In most cases, CHR is actually used for most languages. Alright, so Python uses the function called ord, O-R-D, which stands for ordinality. So it basically says, where in the list, where in the sequence are you? What is your number? That's what ordinality means. And so the ordinality, or which is just basically translates, if I'm talking about an ASCII character, it's just say, hey, give me your ASCII character value. So the ordinality, or the ASCII character value of the character 0 will be 48. I'm just driving this in reverse. Likewise, ord of capital A should give me 65. No, not should, it will. And ord of lowercase a will always give me 97. In pseudocode, we use a function called ASC, which I imagine stands for an abbreviation for ASCII. So the idea is that it turns and takes a character as its input and returns the ASCII decimal value as its result. Now, what we've learned from functions and inverse functions, if I nest a call of a function and its inverse, I just get what I started with. So you don't need to be a rocket scientist to work out what's going to go on here. So this ord 0 is really just going to give me back the value of, let's remind ourselves, 48. And if I CHR 48, I'm simply going to get 0. Ord of A is simply going to give me the value, if you like, of 65. And therefore, if I CHR that, I'm going to get capital A back. And likewise for lowercase a. The equivalent in pseudocode is simply to put an ASC inside a call to CHR. Same effect. Now, we can do some really cool things with this. One of those things is some form of encryption. We can do a right shift or a left shift. So in Python, if I now added 1 onto the ordinality, so if I add 1 onto the ASCII value, that then means, okay, I'm going to take the ASCII, whatever the character is. In this case, it would be, the character 0 would be 48. If I add 1 into that, that gives me 49, which just simply means, hey, move the ASCII character shifted by 1 up, which means instead of when I CHR it again, I'm not going to get 0 back, I'm going to get 1 character along. which in this case is going to be character number 1. Likewise for character A, the ordinate will be 65. If I plus 1 onto that, that's going to give me the character code for B. And so when I say HR it, I get capital B back. Likewise with little lowercase a. It's going to be shifted along from 97 to 98, and that will give me lowercase b. I can also do a left shift by simply subtracting. So for instance, if I did an ASC -1, that will look up the ASCII value of 1, which would be 49. Take 1 away, it gives me 48, and the character code for ASCII 48 we know is 0. Likewise, ASC B -1 will give me capital A, and ASC lowercase b -1 will give me lowercase a. So this is all good and well, but what about if I want to wrap it around? I've got some special conditions on the boundary. So if I'm doing a right shift, if I'm dealing with the numbers, when I get to character 9, I want it to come back to 0. And the way I could do that in Python, so right, if the character I'm looking at, the one I'm doing the ASC on, is in fact equal to character 9, then don't add 1 onto it. Instead, make the character 0 instead. Likewise, Z should wrap around to capital A, and lowercase z should wrap around to little a. What about the pseudocode and doing a left shift? That's -1. Well, for left shift, I just simply look at the upper end of the scale. So if the character was 0, then I need to wrap it around and jump back to 9, or right, so we need to fix this over here. So if the character, I've just duplicated that. So if the character is equal to, so I'm doing a left shift. If the character is equal to capital A, I would then need to wrap around and go to the tail, which would be little a, capital A. And if it was little a, then the character code should be changed to little z, and that would do the left shift. Right, before we move on, we need to also then quickly talk about how strings work in both pseudocode and in Python. Strings are basically just a list of characters, a list of chars. And they are an ordered collection of characters. So this means that these are not random, but they have a specific value, a position rather. And the computers always start counting from 0. So the index, we call it, the index of the first element in my string is going to be character 0. The next character, if I had the string being the string string, string, character number 1, which would be the second character, would be T. Character in position 2, or index position 2, would be the R. Character 3 at position 3 would be an I. Notice, however, that is actually the fourth character in the string. The reason that it's indexed at 3 is because, remember, we started counting from 0. So character at index position 4, or the fifth character in the entire string, is an N, and character at position 5, or the last character, which is actually the sixth character in the string, is the G. So we can represent and we talk about specific letters or characters in the string by putting it in square brackets after the name of the string. So the first character would be represented by S0. The last character in the string would be, in this case, S in square brackets 5. Now there's a predefined function because we don't know how long a string is going to be. It depends how long how many letters you've typed into it. So strings are not always going to obviously be 6 letters long. And to that end, there are two predefined functions. The Python function, they do the same thing, it's just the syntax is a little different. So in Python, there's a predefined function called len. And len will return the length of the string, which means how many characters does the string have. So the length of this string is in fact 6. So the index of the last character will be 1 less than that. So if I go length of S minus 1, that will give me 6 minus 1. So it always gives me the last character as being 1 less than the length. The pseudocode notation is very similar. uses a method call instead. So we go s dot length, which means look up the length of the string s. Again, it has exactly the same meaning. How many characters are there in the string s? In this case, 6. And the last character will be s dot length minus 1, which would be character number 5. If I went to try and go to s dot length, which is character 6, there's no character 6, I would actually get an error. So to this end, let's summarize this. So the first character is always s0, the last character is always len s minus 1 or s dot length minus 1 if we talk in pseudocode. However, before we go into our next step, Python uses something called the range function. Now, the way the range function works is it's been designed to work with this length function. So the way the range function is defined, it generates a list of numbers starting at 0. If I only give it one number, so if I give it the number x, it's going to generate a list of numbers starting at x and going up to, but not including x. In other words, it generates, if I put a 6 in here, it's going to generate 6 numbers. But again, because we start counting at 0, the last number it's going to generate is a 5. So it will generate 6 numbers, but stop after it is just before it gets to this last number over here. It never quite reaches the 6. Why? Because remember, we're counting from 0. That's how they've defined the range function in Python. And this is lastly brilliant, because it means if I want to generate the index range for a string, all I have to do is go range in brackets length s. I don't have to worry about subtracting the 1, because the range function will itself automatically always do that for me. So to generate a range of numbers that indexes a string, I simply go range in brackets length of whatever my string is, and that will always do the job for me in Python. In pseudocode, there's no such thing. I have to actually remember to go s.length minus 1. Okay, so we'll have a look at how that would be worked in a minute. So let's suppose I want to now traverse the string. I want to walk it. I want to go from beginning to end. We use something called a for loop, which is going to count, and I need a variable in both cases. I need a variable x, which is going to represent my index. And in pseudocode, the notation is very straightforward. So I say, right, where do I want my loop to start? I want to start at my first index position, which is always going to be 0, and then I want to go up to the last index character over there, which is in this case is 5. But in general, it will be s.length s.length minus 1. Why minus 1? Because remember, we started counting from 0, and s length is the number of strings, and I can then do things like print out the value of s at position x. What about Python? Python uses the range function, so we need to generate a sequence of numbers using the range. So the way the Python loop works is it looks as follows. We go for x in range, and if I wanted to go up to generate a list of numbers from 0 to 5, I would simply do that. But because of our previous discussion, I know that if I want to generate a list of indexes for the entire string, I simply need to do that. So range, open brackets, length s, and it's always going to be like that. Notice I have a colon. When I press enter in Thonny or whatever editor you're using, it will indent that code. This code has to be indented for the loop to work. And if I wanted to print out each element of the string s, each character in turn, I would simply do that. Notice that the code has to be indented, and I have to have a colon. So we can put this to good effect. If I wanted to do the right shift, if I want to do the right shift on my Python, using Python, I would do it as follows. So t is going to be the string I'm going to build. So let's go through this very quickly. So I'll go for x in right? I need to generate a list of numbers, so I use the range function. I don't know at this point how big the string is, so I'm simply going to use length s. Right, notice I've started t, the string that I'm going to build, my shifted string, as being empty. Now, if I did this, that would just build a copy of the string. Very boring. So in Python, I'm going to first do that, turn each character of the string s into its ASCII code. I'm then going to add 1 onto that ASCII code, but because I need it to be a character, I need to put all this inside a CHR, and that will do the right shift for me. So T will be a new string built up from the string S, where every character has been shifted one place over. The only thing I need to still do here is to say, right, if S is the character at position X, because I'm right shifting it, if it's equal to one of my special cases. So I'd have to do this for all three, but let's suppose I'm only dealing with the numbers in this case, right? So if it was equal to my last number, all right, I would then, instead of doing that shift, I would make t equal to t plus 0, so we get a wraparound. All right, and if it's not, then we do the normal thing of the else. Now you'll notice, okay, that I actually have to have 2 levels of indenting now. 1 level of indenting for everything, so the if and the else should line up under the same indenting for the for loop. There's my first colon, everything indents there, and then I need an indent, a second level of indenting for the if, and another level of indenting for the else. Remember, in Python, whenever you see colon, you should think, I need to indent whatever's underneath it by at least 1 level. So there'd be 2 tabs over here, and there'd only be 1 tab over there. Right, pseudocode, bit more straightforward. We don't have to worry about the indenting, it's style. So, and it's a bit more clear cut as to what I'm doing. Right, so I'm going through the whole string S. What's the index of the first character? It's always going to be 0. Where do I go up to? Oh, I've got to go up to s.length minus 1. Why minus 1? Because I started counting from 0. Alright, and then I do a very similar thing. So t would be equal to t, what it was before. I'm adding on to that, building onto it, the value of sx. Right, so that would build up a copy of the string. Okay, so now we start building this, and instead of using the ORD function in pseudocode, I have to use the ASC function. So that would actually that would turn it into a number. Turn it into a number. I now add 1 onto that. Oops, I'm going to left shift it. I'm going to go -1 in this case. So that would now go 1 character before, and because I need to turn all of that into a character, I need to CHR the whole bunch. Right, likewise, let's suppose I'm only, oopsie, the 2 should be, I've got this all wrong here, for x equals 0, and I'm missing the 2 should go there. Sorry about that. So that makes a bit more sense. Right, so, and then I have my special case. Let's again suppose that I'm only dealing with the numbers, and so I'd go over here. Right, so if my particular string character that I'm looking at the moment, so s of x, is equal to the, because I'm left shifting, if it was equal to the 0, character 0, then I would simply do, I would automatically wrap around. I know the character I want to encode is going to be a 9. Else, I'm going to do that, and I just need an end if, and there's my pseudocode for a left shift there's the Python code for a right shift. Alright, I hope this helps you understand how to do Caesar shifting, how character encoding works, and how you can use it in programming. Mr. Holmes signing out. Thanks for watching.